I'm here to talk to you briefly about our M&D portfolio and how it can act as a foundational layer to your wider asset lifecycle management strategies. GE's actually been an active vendor in the space of monitoring and diagnostics for over 40 years, and today we have a very broad range of advanced monitoring equipment which can really help monitor your most critical substation assets. So Chantal and Thibault have already provided a brief overview of what can be achieved with inspection and testing, which is actually quite a lot if the data is well leveraged. Let me take a few minutes, however, to make the case for online monitoring and how it can really help advance your ALM strategies. It is well proven that continuous monitoring allows for the earliest identification of incipient faults. That's because online monitoring will facilitate you to capture the vital information that happens in between periodic offline testing. Not only that, but it allows you to track and trend that information against operational and environmental characteristics like load and temperature. The collection of that data can be fully automated via remote communications, and the frequency of both that measurement and the data collection can be varied to accommodate the criticality and the condition of the relevant asset. This can really help deliver efficiency improvements both across workforce deployment and planning improvements, as well as enhanced diagnostics of asset health and reduced maintenance. So more specifically, enhancing ALM with online monitoring will help you to reduce the risk of your asset failure and the associated costs. It will help you avoid unplanned outages and minimize planned maintenance activities. Implement a truly condition-based asset management or asset replacement strategy, extend the overall life of an asset and also better manage near end-of-life conditions, and optimize the asset's capabilities without causing adverse damage or adverse aging. In today's session, we don't have time to deep dive all of those benefits, but we can take time to look at just a few of them. So online monitoring can greatly assist asset managers in implementing a truly condition-based replacement strategy via the insights gained from having complete health view of your entire fleet of online devices. You can leverage real-time online monitoring data complemented by any available offline inspection and test data. This allows asset managers to better plan and concentrate scarce capital expenditure on the assets that most critically need to be replaced. But crucially, it also empowers them later in the process to divert that expenditure or to divert those new assets based on true current fleet condition. Equally, online monitoring can greatly assist asset managers in extending overall life and better managing near end-of-life conditions. Asset life can be extended via knowledge of the impacts of loading on health, detection and management of stress conditions, and more targeted condition-based maintenance. Meanwhile, close monitoring of an asset nearing its end of life or when a known issue is present can facilitate safe and reliable continued use of that asset until a replacement is in place. Okay, so we've covered the reasons why for online monitoring, which I hope you can see are attractive. Now let's take a quick look at our M&D portfolio, focusing on the most critical substation assets, namely the transformer and switchgear. So GE's monitoring diagnostics portfolio can be broadly broken into 3 levels. The first level is our monitoring level, which consists of our 1 to 3 gas hydran and mini-trans DGAs, or dissolved gas analyzers. These offer for you to be able to detect, trend, and alert on levels of moisture and key gases, namely hydrogen, carbon monoxide, and acetylene. These are gases that build up in the transformer main tank over the life of the transformer and under fault conditions. This allows asset managers to see developing faults, enabling them to react quicker to urgent cases and to better plan inspection and offline maintenance activities. The hydran and mini-trans devices are very well complemented by the Transport 10, which is a portable full 7-gas DGA device. This facilitates lab-grade measurements to be taken in the substation in less than 30 minutes. Okay, so moving on to the second level, which is our monitoring with diagnostics level. So our Kelman DGAs can measure between 5 to 9 gases, and so cover all of the diagnostic fault information you may need. This remote monitoring with diagnostic capability, coupled with remote communications software, remote communications and software will allow asset managers to utilize standard industry tools to gauge the type and severity of fault conditions. The advanced photoacoustic spectroscopy sensing deployed in these Kelman devices is a highly accurate technique which does not need any gas consumables to operate and which uniquely can be deployed in not only a main tank but also a tap changer compartment, which is a capability which is pretty unique in the industry today. The products in this range are the Transfix, the TapTrans, and the DGA 900. Other than fault conditions in your main tank or the tap changer, the next most likely component to have a problem on your transformer is actually the bushing. But unfortunately, bushing failures can be quite sudden and quite catastrophic. Installing a BN2330 will allow you to monitor the health of your bushing over time by being able to see the change in capacitance and power factor. This device can be deployed either as a standalone monitor or integrated as part of our DGAs. Complementing both our monitoring and monitoring with diagnostics levels is our Perception desktop software, which ships with every monitoring product you buy. This advanced software allows for remote download and storage of the data, insightful visualization tools, and standards-based diagnostics. Okay, so the third level is our holistic M&D solutions, which consists of the MS3000 transformer monitoring system and our Perception fleet software. MS3000 is a powerful and highly flexible platform to consolidate all of the sensing on your transformer into one single HMI. It deploys advanced expert-level diagnostics, reporting, and modeling, including hotspot, insulation aging, tap changer contact wear, cooling efficiency, and dynamic loading. Perception Fleet is an advanced version of our software which can be deployed on a customer server to automatically pull data from a range of GE monitoring devices. It also has an enhanced set of features enabling advanced remote analytics, reporting, health indexing, and fleet ranking. This software is fully complementary and interoperable with GE's wider grid APM software offerings from our ALM and APM portfolios. So we've looked at transformers. Now let's look at the next most critical asset in your substation, namely the circuit breakers and the gas-insulated switchgear. The CB Watts is a compact, modern, and modular online monitoring platform for most types of high-voltage circuit breakers. It measures and checks key parameters every time the circuit breaker operates to gauge its health and prevent future failure to operate. It continuously monitors SF6 gas density, operation and arcing time, contact wear, coil, motor, and pump currents. It also monitors other items in between operations, namely the SF6 gas pressure, the DC voltage source, coil continuity, and the cabinet heaters. So the BWatts provides monitoring for SF6 gas density in the various compartments of a GIS, something which is crucial not only to correct GIS operation, but also very crucial in today's heavily regulatory industry where you need to understand gas leakage rates. It is a self-contained system for up to 10 GIS with up to 30 gas sensors being deployable. It provides future SF6 gas trending alarms, allowing maintenance personnel to better plan refill operations. And the BWatts also offers arc localization so as to enable faster restart of the GIS following an arc condition. The CB Watts and BWatts are flexible to be deployed on circuit breakers and GIS from any manufacturer and can be used to extend the life of aging assets and extend the maintenance intervals whilst reducing the risk of failure to operate. Okay, so for online monitoring to be effective, really we need to consider remote communications to ensure that the data can be leveraged by remote asset management departments and by remote asset management software. For this purpose, GE offers a broad range of flexible communication options for M&D devices, covering all the major substation protocols. In addition, when connecting to GE's grid APM solutions, we can offer a Predix field agent. This field agent is pre-configured and allows easy plug-and-play communications between the online monitoring device and our grid APM. It connects either to grid APM systems running within your own customer network or to the Predix cloud version of grid APM running on the GE cloud. It also enables distributed edge analytics to take place, accommodates a wide range of hardwired and wireless communication options, and all of this is backed up by hardened cybersecurity. So we have taken a quick look at the justifications for online monitoring. We've taken a look at GE's broad portfolio of M&D products, And we've taken a look at how this can be easily integrated to expand and complement your wider asset lifecycle management strategies. So that concludes my part of the presentation, and I thank you for your time. As I take my seat, we will play a short customer video illustrating all of this in action. Okay, thank you.
Each country can't develop without power.
The state of Kuwait is demanding more electrical power.
So the power is very important for socially, security, for financially.
MEW is moving smartly to develop a digital transformation strategy in order to improve the business process and develop new capabilities and business models.
Kuwait is always looking for the state-of-art technology, and we are really keen to work on the digital also substation, the automation system, and this project is one of these starts.
What we have done is that we have turned a fleet of 26 aging power transformers into a fleet of smart power transformers in 15 different substations, where we have installed 26 online monitoring sensors supported by software located at MEW Maintenance Department in Sarhan area.
The system is designed to monitor transformers in substations, whether it be distribution, transmission or generation. That information is then transferred over a communications platform to a software which we provide to the customer, which then analyzes the data being supplied and then using mathematical algorithms establishes the condition within the devices. The information can also be extracted in the field directly using a laptop and the software. You then connect that information via USB cord to the device, download it at the interval, and it will do exactly the same as what the remote feature gives you.
By using this kind of asset performance management solution, it will reduce the failure rate up to 70% and reduce your maintenance cost up to 30%.
The benefits we have seen is by reducing the risk of failure within given financial constraints and by minimizing the impact of failure when it does occur.
It's a really great partnership between MEW and GE, and I really describe this partnership as perfect.